Welcome to Bosch's Virtual Training Labs, IP Basics for CCTV, Module 1, Classful IP Addressing. In this first module, we'll be covering the anatomy of an IP address, classful IP addressing and what it means to your CCTV installation, routable versus non-routable addresses, and some basic troubleshooting commands that you can perform from your command prompt. Let us first start by defining what an IP address is. An IP address is a numerical label that is assigned to computers or devices, also known as hosts, participating in a computer network. That means in your CCTV installation, all servers, IP cameras, iSCSIs, and encoders will all have an individual and unique IP address. Let's look at an IP address in its raw format. An IP address is a 32-bit binary number. For usability, we divide that 32-bit number into 4 8-bit octets. Next, we will perform a simple binary to decimal conversion. This puts it in a more readable format. Lastly, we write this in a dotted decimal notation format, and we have 172.16.128.17. As a CCTV integrator or technician, it is important for you to understand classful addressing. The best technique for remembering your classful IP addressing is called the first octet rule. If the first octet of an IP address is from 1 to 126, it is classified as an A-class address. If you have 128 to 191 in the first octet, it's considered a B-class address. And if there's a 192 to 223 in the first octet, it's a C-class address. 224 to 239 is D-class, and that is reserved for multicasting. You'll notice that 127 is missing from the chart. 127 is reserved for local hosts and loopback. We'll be using this address a little bit later on in conjunction with the ping command for some basic troubleshooting. Let's take a look at why it's important to understand our classful IP addressing. With an A-class address, I can have up to 17 million hosts per network. With a B-class address, 65,000 hosts per network. And with a C-class address, I can have 254 hosts per network. If you're installing or designing a system with 350 cameras, and they're all IP cameras, you can't use a C-class address if you need all of your devices in the same subnet. It's very important that you understand your classful IP addressing. Let's take a look at how we arrived at these numbers. Looking at the basic structure of an A-class address, I have 4 octets. The first octet is reserved for networks. That means I have 2 to the power of 8 for the number of networks that I can have. I have 3 octets left over for the number of hosts that I can support on each network. That means I have 2 to the power of 24. In a B-class address, the first 2 octets are reserved for networks. So I can have more networks with B-class address than I can with an A-class address, but I have fewer hosts. With a C-class address, my first 3 octets are reserved for network, and only my last octet is reserved for hosts. Thus, I can only have 254 valid IP addresses in a C-class network. Now that we understand classful IP addressing, we must also understand that in each IP class, there's a non-routable or private range of addresses. Private non-routable addressing was developed due to the fact that at the time, the IP pool with IP version 4 was being exhausted. Private or non-routable means the following. If you were using a private address in a CCTV system, you cannot get out to the real world unless you have a common default gateway, and somewhere in that system, you are performing network address translation. The same goes for trying to get into the system from the outside world. This is very important as a CCTV installer or integrator that you understand this, because if your customer says, I can't get to my video from home, and you're using a private address schema, you have to realize that to get back in, you need a gateway and NAT. The private non-routable IP schema for an A-class address is 10.x.x.x. For a B-class, it is 172.16.x.x to 172.32.x.x. And for a C-class address, it is 192.168 192.168.1.x.x. Let's take a look at a real-world scenario to see how IP addresses actually function. You're given a CCTV workstation to install in a local area network with the following IP configuration. As we learned earlier, we've been assigned a private non-routable B-class address, 172.16. We know that the first two octets of a B-class address denote the network that the PC resides on. 128.17 is the actual physical numerical address of the PC. The subnet mask is a filter that divides the network address from the host address. This allows routers the ability to forward information without reading the entire 32-bit address. You will notice that default subnet mask for each class IP address corresponds with the network and host octets as we defined earlier. Our default gateway is the entry and exit point from our local area network to our wide area network and/or the internet, and typically it is a router. Now for some very basic troubleshooting. You've installed an IP DINION into a system, and for some reason you cannot communicate. The first step you should take is to check your own PC's configuration to see if it's in the same network or same IP schema that you configured the IP DINION. From your Windows machine, select the Start button and Run. From the Run box, you will type CMD, which is short for command. Select OK, and this will take you to the command prompt. From the command prompt, you want to type ipconfig/all. Once you hit the Enter key, you will be given a list of pertinent data pertaining to your machine, to include the IP address, subnet mask, default gateway, DHCP server if you're using one, a DNS server. You'll also receive information about your MAC address or your physical address. We'll be covering this in the next module. If your IP addressing is in the correct range, the next step is to use the ping command. The ping command is a useful tool that allows you to test communications between 2 points on a network within the same broadcast domain. Here, you'll see that we're going to ping our own loopback address, 127.0.0.1. We previously discussed that the 127 address range was reserved for local hosts and loopback. By pinging yourself, you're testing your own functionality on the network. Now simply use the ping command with the IP address of the device you're trying to communicate with. Once you become certified, and if you ever have to deal with tech support, the first question they're going to ask you is, can you ping the device you're having an issue with? This concludes Module 1. In our next module, we'll be discussing the OSI model, network devices, and how they affect your CCTV installation. Thank you.